We want to establish the identity cosine of theta times the quantity tan theta plus cotan theta equals cosecant theta. Well, certainly the more complicated side is the left-hand side, so we're going to manipulate it to try and get it to equal cosecant theta. So we have cosine theta times the quantity tangent theta plus cotangent theta. Well, whenever you have a set of parentheses, you always want to distribute the expression to remove the parentheses, so we'll go ahead and do that. And we get cosine theta times tangent of theta, but I'm going to rewrite tangent of theta as sine theta over cosine theta. Reason being is I'm anticipating the cosines dividing each other out. Plus cosine theta times cotangent of theta, which can be written as cosine of theta over sine of theta. Now, like I said, on the expression on the left, we have cosine theta over cosine theta. They divide each other out, and I'm left with sine theta plus cosine theta times cosine theta is cosine squared of theta over sine theta. Now you have two expressions that are to be added to each other. To do this, we're going to find a common denominator, sine theta. So I multiply the numerator and denominator here by sine theta, and I get sine squared theta over sine theta plus cosine squared theta over sine theta. Whenever you have the same denominator, you add the numerators. I get sine squared theta plus cosine squared of theta over sine of theta. Well, sine squared of theta plus cosine squared theta is 1, so this result is 1 over sine of theta, and 1 divided by the sine of theta is the cosecant of theta. Because this is the expression on the right side of the original equation, we have established this identity. We're now going to establish an identity using some algebraic manipulation. Another key thing to remember in establishing identities is that when you have a basic identity, sometimes you need to manipulate it so that you can use it to establish the existing identity. We have secant of theta minus 1 times secant of theta plus 1 equals tangent squared theta. First, we notice that the expression on the left is the more complicated expression, so I'm going to attempt to manipulate it to make it look like the expression on the right. So we have secant theta minus 1 times secant theta plus 1. You should recognize this as the difference of two squares. It's going to equal secant squared theta, the first term, squared, minus the last term squared. In other words, if you were to FOIL this, the middle terms would cancel each other out. Now, does secant squared of theta minus 1 equal tangent squared of theta? To help you figure this out, consider your basic Pythagorean identity, which is sine squared of theta plus cosine squared of theta equals 1. If I was to divide both sides of this expression by cosine squared of theta, I would get the following. Sine squared of theta over cosine squared of theta, which is tangent squared theta, plus cosine squared of theta over cosine squared of theta is 1, equals 1 over cosine squared of theta. Well, 1 over cosine of theta is secant theta, so 1 over cosine squared of theta is secant squared of theta. Now the manipulation part. If I subtract 1 from both sides of this expression, I get that the tangent squared of theta equals secant squared of theta minus 1. Therefore, secant squared of theta minus 1 up here in establishing the identity is going to equal tangent squared of theta, and I've established the identity. So this illustrates a key idea. Not only do you have to understand your basic trigonometric identities, but you also want to be able to manipulate them so that you can use these various manipulations of the identities in establishing other identities.